Hi everybody and welcome back. So today honestly really is not anything new. I think you guys I think you guys might have seen from the first time or from the last lesson with graphing quadratics. There's a lot that goes into this. So I just wanted to do some more stuff like this all over again just to make sure everybody was really solid with everything. Again, if you need any textbook information, all of this should come from section 8.3. All right. So we're going to have to do a little bit of work to fill most of, if not all of this out before we go into graphing anything. Domain was one of the first things I did last time because that's always going to be all real numbers. The y-intercept is also pretty easy to do right away. It comes from the c-value of your quadratic. And because we're talking about intercept or intercepts, I will also be looking for stuff like this as an ordered pair. So not just 5, but 0, 5. For the axis of symmetry and the vertex, this is where we're going to need to do a little bit of work. All right, axis of symmetry is, again, negative b over 2a. So we're going to use all of the information from the actual quadratic equation or quadratic function. B is -4, so negative 4 is positive 4 over 2 times 1. So that's 4 over 2, which is 2. And since this is a vertical line, I am also going to be looking for this to be the equation of the line. Vertical line, hoi vux. The axis of symmetry is the line x equals 2. And for the vertex, you're going to want to take that -2 in because the axis of symmetry, again, is also the x value of the vertex. So you're going to take 2, plug it into the function. So let me just 2 squared minus 4 times 2 plus 5. So this is 4 minus 8 plus 5, plus 5. 4 minus 8 is -4, plus 5 is 1. So your vertex is 2, 1. And because, again, the vertex is going to go in the middle of your parabola, you're probably going to get, you're going to get tables like this, that you got last time. So the vertex goes in the middle of your table. And I think I saw a lot of you guys do stuff like this on your homework last time. You can technically pick any x values you want, but in order to keep that symmetric idea in play and make your lives a little bit easier, I'm just going to count. So counting down to 1, 0, and then counting up to 3, 4. 0, again, we already have because that's our y-intercept. The x value of your y-intercept is always going to be 0. So this is 0, 5. And the whole reason why this symmetric idea works is because 0 is 2 units away from 2. So if 4 is 2 units away from 2, you should get the exact same y value. So this should also be 5. And I'm just going to pull the calculator out just to make sure. So this is 4 squared minus 4 times 4 plus 5. And yep, can you see that? There you go. It does get us positive 5, so we're good. 1 or 3, again, when you plug either of those numbers in, you should get the exact same thing, but this we're going to have to do a little bit more work with because we don't have any of that information. So this would be 1 squared minus 4 times 1 plus 5. This is 1 minus 4 plus 5. 1 minus 4 is -3 plus 5 is 2. So the y value for 1 is going to be 2, and so as well for 3. So now we can plot all this. And again, try to make that bowl shape have that nice curve, arrowheads at the end. And before we wrap this up, we skipped over range. This is pointing up, so you're going to have y is greater than or equal to whatever the y value of your vertex is. So it's going to be y is greater than or equal to 1. Okay? And that's it for that problem. And I actually want to skip ahead. Again, I'm going to do these couple problems later. You'll have the answer to them. But I wanted to do something like this with a negative coefficient or with a negative a value because I was getting a lot of questions about stuff like this last time. So the domain is still going to be all real numbers. The y-intercept is still the y value of your function, so it's 0, 3. And the way you would figure out the axis of symmetry and the vertex is still the same as before. Negative b over 2a. So our b value is 2. So this is negative 2 over 2 times. And now that we have that negative in front, that's our a value. All right, our a value is negative 1, not 1 this time. So it's 2 times negative 1. This is negative 2 over negative 2, which is 1. So the axis of symmetry is x equals 1. And then when you plug this in for the vertex, this is where I was getting a lot of questions. All right, we're still taking the value of 1 and we're plugging it into the original function everywhere we see an x. So this is negative 1 squared plus 2 times 1 plus 3. I met with a couple people over Google Meet towards the end of last week when you guys were first doing this. And I remember showing something very similar to this to anybody who I met with on Google Meet. So if that was you, you probably should have seen something like this before. I feel like I might have said this to you guys in person in class. In general, you always have to be very careful when you're plugging negatives into the calculator. I always encourage you to put parentheses around them. Because if you plug like negative 1 squared, I'm going to show this to you. If you plug negative 1 squared into the calculator without parentheses, what you're actually doing, or what the calculator is going to do, is it's going to square only what's directly in front or what's directly below the exponent. So it's only squaring the 1 and then tacking that negative on to the end. So this should get us negative 1, which it does. If we were actually squaring the entire quantity negative 1, we would need the parentheses around it because we know a negative times a negative is a positive. That's where the 1 is coming from that we want. So if we have something that's being multiplied by negative and squared, it's kind of like an order of operations type thing where you would do exponents and then multiplication. So you would square 1 first and then multiply by negative 1. That's exactly what's going on if you have a negative coefficient. Even if you had negative 2x squared, I think there were problems like that on your homework last time. If you had negative 2x squared, you would plug in your x value, square it, and then multiply by negative 2 or whatever your coefficient is, you know? So 1 squared is 1 times negative. This is going to get us, I'll do this over here, negative 1 plus 2 plus 3. So negative 1 plus 2 is 1, plus 3 is 4. So the vertex is 1, 4. And then the rest is pretty much exactly the same as last time. The 1, 4 is going to go in the middle of our table. We're going to count up, we're going to count down. So 2, 3, and then 1, 0, negative 1. Same kind of thing as last time. We have the 0 already when x is 0 because that's our y-intercept. So 3 is going to go right here. And because it's equidistant, it's symmetric, 3 should also go with the 2. Negative 1 and 3, you are going to have to do some work by plugging it in. Again, it doesn't matter which one you plug in. You should get the same thing. I'm going to go with negative 1. And again, I'm going to be careful with my parentheses and with the order of operations. So negative 1 squared is 1 times negative. That's negative 1. This is minus 2 now, plus 3. So negative 1 minus 2 is negative 3, plus 3 is 0. So 0 is going to go here, and that means 0 should also go there. Those are our x-intercepts. So if you had decided to factor this, those should be the solutions that you get when you factor and when you solve. I think there are some questions on tonight's or on today's assignment that do also involve zeros and stuff. So just be aware of that. you might be asked to find zeros, which just means setting your function equal to 0 and then factoring it and solving it. Or again, you could always do quadratic formula if you would rather. But now we're just going to graph it. Three, 3, 0. Make the curve, extend the line, draw the arrows. And that's our parabola. I think I did a pretty good job drawing that. So again, I'm going to do the other two later. You'll have the answers to those. Why are there so many crumbs on here? And that's pretty much it. I think you guys know by now where to find me if you need any help. And yeah, that's it. Talk to you guys soon.